Well, greetings, mathletes, and welcome back. Um, we're going to be talking about sequences today. In fact, we're going to narrow in on a particular type of sequence. In particular, we're going to be talking about an arithmetic sequence. Now, we have been looking at summations, and one of the things we're going to do is add up all the terms of a sequence. Excuse me, I think I have the hiccups. Let's see if I can get those to stop. Okay, I think I got them to stop. Okay, anyways, um, yeah, so we need to talk about what a sequence is, how you define one, and in particular, what an arithmetic sequence is. Really, an arithmetic sequence, and this is one of the things I want you to kind of keep in mind as we go through this, is that an arithmetic sequence has the same equations as a line does, right? So it in that mx plus b form, all arithmetic sequences can be modeled after that. So let's take a look at what I mean by this. Okay, so I'm going to start out just by looking at an arithmetic sequence. Okay, so here's some terms of an arithmetic sequence. And really all a sequence is, it's literally just a list of numbers, right? If the numbers have a particular relationship with each other, then they usually fall into a certain type of sequence. But let's see here. So let's go 3, 5, 7, 9, 11, 13, 15. And you can probably predict the next two terms here just by looking at this. You can see some patterns in here of what I'm doing, right? 17, 19, and let's just assume that goes on forever for right now, right? It keeps going the way it's going. Now, looking at this, you could probably write down the next few terms of the sequence, right? You can look at that and go 19, okay, so let's 21, 23, 25. You can probably see the rest of it, and it's because this follows a very specific pattern, right? The first term is the first term, but what makes this arithmetic particularly are the differences between terms. And literally, I mean difference mathematically, not just like the things that aren't the same. A difference in mathematics is what you get from subtraction. And if I take any term here and subtract one from subtract the bigger one from the smaller one, I always get 2. And so I have a difference of 2 between each term, right? To get to the next term, each time you add 2 more. And so there is one way to describe an arithmetic sequence this way. Each term of a sequence is called AK. So the first term would be A1, second term would be A2, right? All the way up to AN, whatever N happens to be, right? And so in this particular case, this is defined, AK is equal to AK minus 1 plus 2. Now you notice here the K just means pick a term. K, if I have K minus 1 on the other side here, that means that's the term before it. So each term is found by adding 2 to the previous term. That's what this notation means. Now, this notation gets used a lot more later on in calculus, particularly in the second semester. You spend a lot of time on sequences. So the notation here and just understanding how things are fit together is going to be important, just having some familiarity with this. Okay, now there's another way to define this, though. Because each one of these, if I look at this sequence, right, it starts at 3. The next one is 3 plus 2, right? And I'm going to write it this way, 3 plus 2 times 1, right? So this is 3, this is 5. And then 3 plus 2 times 2 gives me 7. And then 3 plus 2 times 3 gives me 9. I almost wrote 8 there, right? And you notice these are the first few terms of the sequence. Now, if you look at what we're doing here, I have my initial value. And then for every single unit that I move over, I'm adding 2. So to move over 2 spaces, I have to add 2 2s. If I move over 3 spaces, I add 3 2s. And so you can kind of see that there's a formula in here, because this ends up being your index, because that's what's changing. and it ends up being, and this isn't quite the way it gets written usually, we can write that any term of this, AK, is the first term plus the index, right? And it ends up being K minus 1 times the common difference. Now, the difference between each terms is called the common difference. So if we look at this, let's just look at this sequence here. So I have 1, 2, 3, 4, 5, 6, 7. So let's say we want to find the seventh term. Let's see if the formula works. This is always a good idea. When you think you have the formula, test it to see if it actually predicts what it's supposed to predict. If I want the seventh term, I should be able to just plug 7 in for K here and get the seventh term. So let's see if it works. This would be 3 plus, oops, that's not a 7. Try that again. 7 minus 1 times 2, right? And remember, we want this to be 15. So 7 minus 1 is 6. So 3 plus 6 times 2 is 15. And it matches, right? So I can actually use this formula to find any term of the sequence that I want. So it's really a little more powerful of a formula because of the fact that I don't have to know the previous term to find the next term. All I need is the first term and to know what the common difference is. And so that actually gives us a formula for the kth term, and I swear it's called that. I'm not making that up. It's called the kth term, would be AK, is equal to the first term, A1, plus K minus 1 times the common difference, right? So you can find the common difference by finding any two terms and subtracting them, right? Or excuse me, any two consecutive terms and subtracting them, right? So if I wanted to know the common difference up here, I could just pick 13 minus 11, that gives me 2. Or I could go 19 minus 17, that gives me 2. 7 minus 5, that gives me 2. So if you take any term and subtract the previous one, it will always give you the common difference. So really what you need to determine an arithmetic sequence, you need A1. So these are the things you need. And D. If you have those two things, you can do anything you want with these sequences, right? It really determines everything. Then, and after we go through this a little bit, we're what's the word we're going to learn how to add up all the terms of a sequence, right? And we kind of did that last time with the summations, but we kept them really small. We're going to have formulas today to handle things that, there's sums from 1 to 1,000 of something. We'll be able to do that in just a few steps. So it'll work out real nice. Okay, so let's go ahead and take a look at this. Okay, so one of the tasks, and I just want to make sure you understand what the tasks are here, is to determine an arithmetic sequence given some information. So one of those pieces of information, let's turn the pen on, is they give you A1. So let's just pick an A1. Let's say that's not the steak sauce, although this is better than steak. Anyways, A1, let's just pick, let's say it's 5. Right? I'm just picking a random number. There's no particular reason it's 5. You can pick anything. And then our common difference, let's say it's 3.5. Now, some of the things you'll be asked to do. Right? The first 6 terms of the sequence. Forgive my writing. I swear it says exactly what I just said out loud. Write the first 6 terms of the sequence. Okay, well, the first term, it's given to you. That's A1. So it's 5. And then we have to figure out how to get from the first term to the second term. Well, when you have an arithmetic sequence, it's always AK is equal to AK minus 1 plus D, right? So whatever your common difference is, that's what you just keep adding. So that means the next one is 5 plus 3.5, right? So that gives me 8.5. The next one is 8.5 plus 3.5, right? And that would give me 12, right? So 5 is still 5. Then we have 8.5. And you notice I'm just adding 3.5 each time. So if I add 3.5 again, right, that gives me 15.5, right? And then I get 19. So how many is that? 1, 2, 3, 4, 5. And then if I add 3.5 one more time, and I'm not going to write it down this time, that should give me 22.5. All right, so what we just did was we wrote down the first 6 terms, right? So it's just showing that you understand how these numbers fit together, right? So it's, again, we're not going to get into the heavy math on this. This is just giving you a feel for it. So when you see it again, it's not completely unfamiliar. Okay, so that's writing out the first 6 terms. Now, what if I wanted a formula for this, right? So, you're walking down the street here and you know already that this is your A1 and this is your common difference. And what if someone jumps out from behind a dumpster and says, yeah, well, what's the 50th term? And he has a gun. It's not that ridiculous, right? Maybe I just live in a rougher neighborhood than you. I don't know. Anyways, so we have to figure out a formula that will give us the 50th term without having to write out all of the other things. Well, we already know, let's see, we have this, but we also saw before that AK is equal to A1 plus K minus 1 times the difference, right? So let's see. That means we need A1, which is 5, plus 50 times 3.5, right? So that's what we have here. I just filled everything. Oh, not 50. 50 minus 1. I'm glad you guys caught that. Right, so I'm going to write 50 minus 1, just so we can see the whole thing. So that means that this is 5 plus 49 times 3.5. And we are going to need a calculator for that. So let's see what we get. Well, we don't need it. We could do it by hand, but plus 49 times 3.5. So I get 167.5. So that means the 50th term is 100. Did I say 67 or 76? 76. I said it backwards. 76.5. Right? And so it's just a matter of being able to figure out what the common difference is and your first term. If you have those two things, you have pretty much everything determined about the terms of the sequence. Also, another thing you'll want to do, you want to be able to do, let me go ahead and get rid of this. If someone gives you terms of a sequence, you should be able to figure out the formula of the sequence from that sequence, especially if you know it's an arithmetic sequence. So let's just see. So I'm just gonna give you an arithmetic sequence. I'm telling you it's arithmetic. Let's do. Well, this always works better with the actual things on. Let's try it again. There we go. So let's say I'm starting with 3. Next term is 7, 11, 15, 19, 23. Right, so you're given this, you know it's an arithmetic sequence, and someone asks you for, I don't know, let's say the 25th term. Okay, so let's see what we can deduce here. Again, what we do know is that a k, any term in this, is going to be the first term plus k minus 1 times the common difference, right? So let's see, the first term we know. We know the first term is 3. Now we need the common difference. Well, we find that by picking any two numbers on this, or any number on this list, and subtracting the number before it, right? You should get the same answer every time. So 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is 4. So that means D equals 4. So now this is k minus 1 times 4 is our kth term. Now, I do want to point something out because I'm writing it in this form. Sometimes you see these sequences, they get kind of meshed around a little bit. Like this might be difficult to plug things into for whatever reason. So you decide to go ahead and distribute the 4. Right? And then collect your like terms, and I end up with -1 plus 4k. So you can actually use either formula. You can use this one or this one. Right? You notice that this isn't the first term anymore. Right? That's a -1. That's what would have come before the first term. So it does mess around a little bit. So it looks a little different. You have to massage it to get it into this form. It's perfectly satisfactory to use this one. Right? But now that we have a formula, if I want A25, then it's going to be 3 plus 25 minus 1 times 4. So it's 3 plus 24 times 4. And 24 times 4 is what, 96? Because 25 times 4 is 100, so that should be 4 less. So it's 3 plus 96, which makes it 99. Right? So the 25th term of that is 99. Now notice how we kind of pieced it together. We weren't given a lot of information. We were given a list of numbers. We had to look at the common difference between terms and know the first term. Those were the main things we had to get a hold of. Okay, so that's about as much as you need to know as far as computing the terms of a sequence. The second thing we need to cover today is how to add up the terms of a sequence. Now, if it's a short list, it's not a problem, right? We know how to add numbers. But if you have 1,000 numbers, that is going to take way too long. So we need to find shortcuts. In fact, that's mostly what math is it's a bunch of people who want to be lazy, so they work really, really, really hard at it. It's an active pursuit of laziness, if that makes any sense. Okay, so adding things up. There's kind of a classic example of this, and I'm going to use it. So actually, I'm going to turn on the pen, then I'm going to use it. Okay, so the classic example here of adding up a sequence is adding up this sequence. Let's just go, 98, 99, all the way to 100. Okay, so we're going to work out this sum. Now, we're not going to do it term by term. That's way too much work. What we are going to do is suppose that we know what the answer is, right? We're just going to say, well, let's just say the sum is S, right? We know it has a sum. We just don't know what the number is, so we're calling it something. Well, S is also equal to that sum in reverse, right? So I could start adding at 100, or I could start adding at 1. So I'm going to put the 100 this way, plus, plus 99, plus 98, plus 97, plus ... plus 3, plus 2, plus 1. All right, so I have these things listed twice. And what we're going to do here is we're going to add straight down, right? We're going to take each one of these sums straight down. So over here, S plus S is 2S. 1 plus 100 is 101. 2 plus 99 is 101. 3 plus 98 is 101. And 4 plus 97 is 101. So I'm guessing you're seeing a pattern here. Going to the other end, 98 plus 3 is 101, plus 101, plus 101, right? It's 101 all the way down the line, right? If you add from opposite ends, which is really convenient because we know exactly how many 101s are being added. There's one for every term, right? So there's 1, 2, 3, all the way up to 100 of these 101s because there was 100 terms in the sequence in the beginning. So what we just did, we added the first term to the last term, and then we multiply it by the number of terms, right? There's 100 terms, so that's 101 added up 100 times. And this is still times 2 at, right? It's still times 2s. So if I divide by 2, the sum, which we had decided that's the number we're looking for in the first place, is equal to 101 times 100 over 2, which is equal to 5,050. Right? Because it's basically 50 times 101. You can usually simplify this down real nice. Okay, so let's look at what we did here. We started, and by the way, keep in mind this only works for arithmetic sequences. We started by listing the terms forward and backwards. Right, all the way to an minus 1 plus an. And then we did the other one from this end, an plus an minus 1 plus dot 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 plus a2 plus a1. And what we found, and this is what makes it unique to the arithmetic sequence, is that with an arithmetic sequence, all of these sums are the same number, right? No matter how you add them, it comes out to the same number, and that number ends up being a1 plus an, right? And so we took that and said, okay, we have a1 plus an. That's the first term plus the last term. That's where we got the 101 from, right? As we added the first to the last term. But there are as many of these pairs as there are terms in the original sequence. So whatever this highest number is, n, is what we're going to multiply this by. Now, adding these things up, we saw that we created twice the sum. We didn't create the exact sum, we created twice the exact sum. And so we have to pare that down by 2 by cutting it in half. Now, the way I remember this this formula, I actually don't remember it this way. I rewrite it in a different way. I'm going to change the color so we can see what I like to look at. I like to look at it this way. It's the average of the first and the last term, right? Now, if it's the average, since all of the averages are the same, that average represents every sum. And so there's n of them, right? There's n terms in there with these, and this actually represents that particular mean. So this is how I like to remember it. It's the number of terms times the average of the first and last term, right? You could also look at it this way if you wanted to. It's half the number of terms times the sum of the first and the last term. That's another way to look at it, right? So there's a lot of ways to handle this. This is correct, this is correct, and this is correct. And the best thing you could do is just try it once each way, because each formula is a little easier depending on certain contexts, right? But remember, it's the average of the first and last term multiplied by the number of terms. That's how you get the arithmetic sum. Okay, so let's go ahead and try one of these. Let's see what we can get here. So let's see. Let's go ahead and clear this off. There we go. Okay, so let's say we have this this summation of a sequence. By the way, we're not going to get to it this semester, but just so you understand, if I take the summation of a sequence, this is called a series. And I'm just saying that so that so you don't get too confused. We were actually, all those summations we did last time were a series. If we're adding up terms, the terms come from a sequence. The sum is the sum of a series, right? And so it's a real subtle difference, but it mostly has to do with the series is the part that you add up. Okay, so the sum of a sequence is a series. Okay, now we want the sum. Where did I put it? There we go. Let's say k equals 1 to 50 of 3k plus 5. Okay, so you could write out a few terms if you wanted to. So you plug in 1 first. So 1 plus, okay, so the first term is 8. Then let's see here. If I make k 2, that makes it 6 plus 5. That makes it 11. K would be 3. That'd be 9 plus 5. That makes it 14. And that's going to keep going. And then the last term I have here would be plugging in 50. And 3 times 50 is 150. Plus 5 is 155. And I know I have 50 terms here because this counts from 1 to 50. Right? If this starts at 1, this is how many terms you have. Okay, so I have an idea of what this thing looks like. And I can see I'm adding 5 each time. So that's my common difference. And that's always going to be, wait a minute. Let me look at that one more time. 14. Oh, common difference is 3. That's why I'm looking at this all wrong. Between 8 plus 3 is 11. 11 plus 3 is 14, right? And it goes on from up there. Sorry, I actually do have a problem with 3s and 5s. I always get them mixed up. I'll say one and write the other. So, anyways, I can usually catch it. So the common difference is 3. I know there's 50 terms. I know the first and the last terms. So if I want the sum of this entire thing, remember it's the number of terms times the average of the first and the last term. That's a 1. Let's make it look more 1-ish. There we go. Right? So those are the only things we need. We need to know it's an arithmetic sequence. If we know it's an arithmetic sequence, we need the first term, the last term, the number of terms. Those are the only things you need. First term is 8. Last term is 155. N is 50. Now, you can do this arithmetic in a lot of different ways. I'm going to do this. I'm going to cancel the 2 and the 50 to make this a 25 because that's just easier to plug into the old calculator. And then we'll pull that back up. And let's see here. Oh, I covered it. There. So it's 8 plus 55. Oh, excuse me, 8 plus 155 times 25. So we get 4,075. Right? So you can see it's not a huge task. Usually the toughest part is figuring out that you have an arithmetic sequence so you know which formulas to use. Right? So, but these things do get used very extensively in calculus. So this is kind of an important concept, although it will all be covered again in calculus because we're actually getting to the point in the semester where this is a little bit kind of like extra stuff. So this is material we always want to get to. All right. So the main thing I want you to take from this is that you can take something like this, you can figure out terms of it, right? And in fact, this would actually be a sum since it's a summation. And if you want to know what all those things are added up, We have a formula for it. All you have to do is plug in. You need the average of the first and last term, and you need the number of terms. Okay, so let's try one more here. But this one I want to see if we can figure it all out. So here's a sequence. Let's do, yeah, that'll work. 2, 7, 12, 17. So what I want you to do is find the sum of the first 40 terms. Okay, so see if you can do this from scratch, all on your own without looking at anything. Let's see if you can just piece together what you need and compute the sum. So go ahead and pause it here and see what you can do. And then when you're ready, go ahead and play and we'll go. Okay, so I'm assuming you have worked on it, you have paused, and you are at the ready with an answer. So let's see what we got here. So first of all, if I'm going to use a formula for this, I need to know the first term, the last term, and the number of terms. Okay, so if I'm adding up the first 40 terms, n is 40, right? I know A1 is 2. What I'm missing is the common difference because I'm not going to be able to compute the 40th term unless I know what the common difference is. And so I'm just going to check. Let's see. 7 minus 2 is 5. Okay, so that's a difference. 12 minus 7 is 5. So that's the same difference. 17 minus 12 is 5. So we have a common difference of 5. So D is equal to 5. So if I want some AK, remember it's A1 plus K minus 1 times D. Well, I just need to plug my stuff in now. Let's see here. It's the first 40 terms. I know A1 is 2. I know my common difference is 5. So any particular term of this is 2 plus K minus 1 times 5. Well, in this case, since the last term is 40, so AN, which is our last term, is 2 times, not times, plus. Two plus 40 minus 1 times 5. And let's see what that is here. Actually, this is the better way to compute it because 5 times 40 is 200, right? And then distributing the 5 to the negative 1 gives me a 5. So I have 200 minus 5. This is 195 plus 2. Okay, so we have our last term now. A40 is 197. Okay, so we have all these pieces. It's just a matter of putting them into the formula now. Right, so the sum from K equals 1 to 40. Well, this handwriting is bad. Hang on. So the sum from 1 to 40 of, let's see here, we put this together, this guy, 2 plus K minus 1 times 5 is going to be equal to the first term, or yeah, let's do 40, the number of terms, times the average of the first and last term. 2 plus 197 over 2. Again, I can do this and make that a 20. This ends up being 199. And so, I have a picture in the way. Let's jump up here. Right, so if I work all that out, 199 times 20, well, let's just do it this way. 3,000 980 is what we end up with. And so it's just a matter of collecting all the pieces, but sometimes you have to play with it a little bit because you're given, well, it's kind of like being given a toy you have to put together, right, to use. So you have to kind of piece these together before you can use stuff. But that's actually the last of the material that I want to cover this semester. Um, I'm not going to push any more in because this stuff is going to be on your final, and I just kind of want to wrap it up at this point. So let's see here. Yeah, so until next time, keep your pencils and your wits sharp.